Hi, I'm Zoe,
And I'm Alan.
and today we're going to present our COGS 189 BCI final project.
A distractive working environment and an overly exhausted mind can greatly undermine our productivity, but we are often unaware of these factors during work. In our final project, we want to create a system that designs an optimal environment and plan for people by recognizing their mental states during work. Our goal is to use EEG potentials to determine whether the user is in a stressful and unproductive working state, and then provide them with constructive and real time feedback using a computer program so that they can be more efficient. Hence, we decided to come up with our Focus Up project to achieve this goal. In the project, we plan to use NeuroSki to record EEG signals. This could enable us to measure the user's real-time attention level during work. After processing the data, we could then provide a terminal-friendly interaction pane to remind the users to take a mindful break when they are being stressful and unproductive.
Here are some resources from class readings that are relevant to our project. The first paper states that regular BCI is limited because it still requires the user to translate their goals into specific actions, such as thinking of an object, to make the computer understand their commands. A passive BCI, on the other hand, is an adaptive HCI that uses real-time neural activities as implicit command for the machine. It looks at the user's cognition in order to build and keep updating the model. Our approach is based on the idea of passive BCI, since rather than asking the users to actively control the programs themselves, our program attempts to self-adjust directly based on the user's brain signals. Our approach is also inspired by this paper. This paper introduced a way of measuring workload in real time with EEGs and ERPs by looking at the user's P300 signals. One important message from this paper is that we should take into consideration of the user's mental state, which is critical for performance. Measuring the mental workload and adjust accordingly can be useful in creating an optimal system for the users. This is very relevant to our project since we're also trying to create a better work condition for the users based on their mental states. In paper Brain-Computer Interface a Review, we also learned about some of the useful brain waves for measuring mental effort. The first one is beta wave, which indicates a wide awake and focused mental state. And the second one is alpha wave. It indicates a more relaxed state since an increase in mental effort would reduce alpha activity. And then third one's the theta wave, which is related to drowsiness, and the last one is delta wave, which is in a state of deep sleep.
Just as many projects that we have done in the past, we encounter many obstacles in the Focus Up project. In fact, the most critical obstacle that we faced was at the beginning stage, connectivity issues. Both me and my partner only have Macs, and the NeuroSki development guide for Mac is actually pretty poorly documented. Even though we went to office hour many times to try to fix the issues, we were not able to get it connected at the end. Therefore, we decided to use the Mindwave mobile tutorial app on iOS created by NeuroSki to obtain information about brain signals instead. We invited 6 participants to join the experiment, where we actually monitor the graphs produced by the app to try to understand the patterns of the brain signals read by the headset. And then after inspecting, we used the findings to generate random brain signal data in our program based on the user's current time, which is, this is passing our program to run. Now we will show a short demo of our working prototype. In order to run the project, we'll basically type python GUI.py in our terminal. And then as you can see, the GUI panel will pop up. And then if we want, it is pretty intuitive for the user. So if the user want to use the program, the user simply press the start program button. And then as you can see, it will read the current brain signal, and then it will tell the user his or her current brain signal as well as the attention level and meditation level. The text of meditation and attention level will be red if it's very low, and it will be orange if it's relatively low, and it will be blue if it's pretty high. Yeah. So as you can see, and when the program reads a certain tiredness of brain signal received by the user, we actually pop up a alert window showing telling the user that he's not actually concentrating well enough, and then we want them to actually take a break so that they can be more productive later on. And so after they click OK, we actually will play a music for the user to relax. Yeah, and so if the user wants to actually stop the music, he could simply click the button. Yeah, and then later on, as you can see, the program is still here. So if the user wants to continue using it, he could just click start again, and then it will be resetted to the beginning state, and the user could continue using the program. Yeah, and the user could pause it if he wants, and resumes it. Yeah, after using the program, the user could close window. And that is basically a quick demo of our app. Hope you like it.
And here's some limitations for our project. As we mentioned earlier, one of our biggest uncontrolled factors was due to the inability to read the real-time EEG data. Since we're only approximating the value of attention level on the MindWave app on phone, our classifier can be really inaccurate in some sense. Also, since we have no access to the MindWave app's backend, we have no idea how the app actually processes the signals and how accurate the algorithms are. And lastly, our sample size is really small. It's only 6 participants, so the power of our study is not high enough.
Yeah, and we actually learned a lot in this through this project. First of all, we learned that the complexity of processing EEG signals is really is a lot. So raw EEG signals can be very hard to organize and restructure. In our program, we classify the brain signals received into different waves, including alpha, beta, delta, and theta, as well like what we explained in the related work. If the value of certain wave that we receive reaches a certain threshold, it will indicate that the user is actually tired. Hence, the program would suggest him to take a break, and then we will play the music for him to relax. In the real-world application, this processing data part could actually be way more complicated and complex. Yeah, and then in this project, it is also our first time to get exposed to GUI, which stands for Graphical User Interface in Python. Not only these, the project also helped us to get a general idea of what it takes to build a BCI system. We will try to learn more on ourselves to overcome the obstacles that we encountered throughout this time, and we hope that we can make the project better.
And for our next step, we definitely want to actually get access and process real-time EEG data to actually make our program applicable. We also want to create a better classifier for the actual EEG data to increase the accuracy for the attention level threshold. And in the future, we also hope to take into consideration of not only the healthy users, but also those with learning disabilities, and see how we can benefit them with our approach. And last but not least, we want to implement more features for our program. Some features we're considering are the ability to turn off Facebook and other social media notifications when the user is highly focused on work, and also to provide incentives to encourage the users to stay focused. Some examples might be planning plans or getting rewards. And then lastly, we want to have a real-time brain signal visualizations for them. And that concludes our presentation. Thank you.
Yeah, thank you for watching.